Alright, welcome back. Intro to Engineering. This is the last activity for 5.8. So under Course Content and underneath the Home tab, we're going to go to Unit 5. Unit 5.8, Instant Challenge, Low Density Supersonic Decelerator. Alright, this is the assignment, and this is a design challenge, so you'll be in groups of no more than 4. I'm going to recommend 2 to 3 though. Up here, 2 to 3, I say it. And then with direction from your teacher or your sub, you're going to create a solution to the following design challenge. Okay. Remember to record your design process. Once again, the grading scale comes down to the point of did you or did you not use the design process to solve this? Okay. And once again, you could win and have really bad documentation and get an F, or you could lose, have the best documentation and still get an A. So it all comes down to documentation. So the problem statement is you've been hired by NASA to develop a new system to safely deliver cargo that is being dropped from the atmosphere to the surface of other planets. The materials you have provided are here: scissors, rulers, clear tape, digital scale, stopwatch, string, sealable plastic bags, washers or marbles to serve as a mast in the spacecraft, old file folders or cardstock, trash bags, grocery bags, wrapping paper, tissue paper, plastic tablecloths, all things that you can use. You were to design a drag device to slow the weighted spacecraft from a specified height of at least 2 meters. All right. In the past, we've dropped this from the 2nd floor of the library. Depending on the time of year where we can go, we might figure out something else out, but it will be at least 2 meters. Which is from the ceiling to the floor. Data gathered in this challenge, you need to calculate the surface area of your object. So whatever you create, you're going to calculate the surface area, mass, volume, and density, as well as the descent time. So to simplify this, okay, surface area is if you create an object that's a circle, okay, you should be able to calculate that. If you calculate something that's a square, you should be able to calculate that. If you can get a rough idea, all right, I'm not going to pull out a ruler and measure this specifically, but generally looking at something, I could give you an idea of square inches, what it is roughly. And if you're off by a lot, then I can tell you just made up a number, okay? As far as mass and volume and density, same thing. Looking for rough numbers, one thing to consider, density, is you're going to use different materials. So I would look at the density of generic material. So if you use a trash bag, look at the density of plastic. Specifically something like type 1 plastics like PLA, or not PLA, but polyethylene. Would be something like that. So what is the density of polyethylene? Descent time would be however long it takes from let go to the time it touches the ground. Mass, you should be able to figure that out if you can weigh it, right? If you can weigh it, then you should be able to determine the mass using some other formulas. And then volume. A complicated way to do it, but would be to calculate it by area and all that. But what I would recommend is when the project is over, if you talk to Mr. Montgomery, and I'll tell this, make sure the sub knows this as well. But if you talk to Mr. Montgomery and we can borrow a graduated cylinder from him, you could literally, at the end, once you're done, not before, but once you're done, tear apart your design and anything that was used in it, and then stuff that into a graduated cylinder and go by how much water displacement that would be, since it's just a bunch of odd random objects. Okay. Performance is going to be determined by a ratio, so the amount of time divided by the total grams. So the lighter your object, the more time it stays in the air, the better ratio you would get. For volume and density, I want you to select any material through Inventor you want and use that information, okay, to determine. Design criteria. The overall mass of your device cannot exceed 50 grams. you must have at least 5 separate angled edges, so it can't be a circle. Okay, at most it can be, or at the least it can be a pentagon. Okay, test drops must be from at least 2 meters. Okay, and then there's a template provided. Excuse me. I will provide this to the substitute, but basically it ends up being a little triangle that folds into a pyramid, and then your cargo would go in that. Your team is going to receive 2 points for your problem statement, 2 points for criteria and constraints, 2 for brainstorming, 2 for final sketch, 2 for your build instructions, 2 points for the test and reflection, 2 points for redesign, and 2 points for the presentation. Up to 5 points for teamwork, and then your first place will get 4 points, second 3.5, third 3 points, fourth, fifth, and etc. will get 2.5. All right, so just something to keep in mind while you're doing this. Groups 2 or 3. If you have any questions, talk to your classmates, talk to the substitute. If you have the opportunity to email me and I have the opportunity to answer, I will get back to you. Otherwise, good luck and have a good day.